These are Maxwell's equations. They describe how electric and magnetic fields are created, how they circulate, and how they propagate as light. The symbols epsilon 0 and mu 0 are the electric and magnetic constants of free space. Divergence tells us where the field lines begin or end. Curl tells us where the field lines circulate. We will now understand each equation physically, mathematically, and visually. The first equation is Gauss's law for electricity. It says electric charge is the source of electric field. In differential form, the divergence of E equals charge density divided by epsilon 0. Positive charges act as sources of electric field lines, and negative charges act as sinks. In integral form, the total electric flux through a closed surface equals the enclosed charge divided by epsilon 0. If a closed surface contains net positive charge, more electric field leaves than enters. If it contains no net charge, the net electric flux is 0. This equation connects charge distribution to electric field. The second equation is Gauss's law for magnetism. It says there are no isolated magnetic charges, or magnetic monopoles. In classical Maxwell theory, the divergence of B is 0. In integral form, the net magnetic flux through any closed surface is 0. Magnetic field lines do not start or stop. They form closed loops. If you cut a magnet in half, you do not get an isolated north or south pole. You get two smaller magnets. The third equation is Faraday's law. It says a changing magnetic field creates a circulating electric field. In differential form, the curl of E equals minus the time derivative of B. In integral form, the circulation of electric field around a closed loop equals minus the rate of change of magnetic flux through that loop. The negative sign is Lenz's law. The induced electric field opposes the change that created it. This is the principle behind generators and transformers. The fourth equation is the Ampere-Maxwell law. It says magnetic fields are produced by electric current and by changing electric fields. In differential form, the curl of B equals mu 0 times current density plus mu 0 epsilon 0 times the time derivative of E. In integral form, the circulation of magnetic field around a closed loop equals mu 0 times the enclosed current plus mu 0 epsilon 0 times the rate of change of electric flux. Maxwell's addition, the displacement current term, was crucial. It fixes Ampere's law for a charging capacitor and makes electromagnetic waves possible. Now put the equations in empty space, where there is no charge and no current. Gauss's laws say the fields have no divergence. Faraday's law says a changing magnetic field creates electric field curl. The Ampere-Maxwell law says a changing electric field creates magnetic field curl. Combine these two curl equations, and each field satisfies a wave equation. A changing electric field creates a changing magnetic field, and a changing magnetic field creates a changing electric field. The wave speed is 1 over square root of mu 0 epsilon 0, which equals the speed of light. This was Maxwell's great prediction. Light is an electromagnetic wave. Summarizing Maxwell's equations, Gauss's law for electricity says charges create electric field. Gauss's law for magnetism says there are no magnetic monopoles. Faraday's law says a changing magnetic field creates circulating electric field. The Ampere-Maxwell law says currents and changing electric fields create magnetic field. Together, they unify electricity, magnetism, and light.